Hi guys, welcome to tutorial 10, question 2. Let's do this. As always, I'm going to put the question right over here, pause the video, attempt it yourself, and then we'll go through it together. YouTube has this feature, the eye thingy. I'm going to put the exercise 1 up there and in the link in the description below. And watch that first if you want. I mean, they are connected, so it makes sense if you watch that first. And come back and watch this. And yeah, so for the invariant, I'm gonna put the DFA right over here so you can see it. Here are the state invariants. So Q0, right, is one of them, which the string is empty, right, or the string has no bad zeros, right, because it can't, right, and ends with a 1, or the string has no bad zeros and ends with a 2, 0 in that order. And then Q1 is another one, which is the string has no bad zeros and the last symbol is a 0 and the second last symbol is not 2. It's just not possible. It's not a 2. Then another invariant is Q2, which the string has no bad zeros and the last symbol is 2. And there's Q3, where the string contains at least one bad zero. Now, what these invariants that I told you, they cover all the strings over the alphabet, right? And no string satisfies multiple invariants, more than one invariant at the same time. And that's very important to know. And to prove the correctness, we're going to start with the base case, which is, epsilon, right? That's the first and foremost thing. It's that epsilon satisfy the invariant from Q0 because that's where we start, right? And as you remember, that does satisfy our Q0 because literally the first sentence for it is that the string is empty. So it satisfies our base case and, yeah, that's pretty much it for the base case. All right, now we have to prove how these transitions work, right? So for each of these transitions, we have to show that if the invariant Q holds for string W, then the invariant R should hold for string WA, A being one element that's added to W. And, meaning that every time you add something to a string, there should be another invariant ready that matches it. And we do this separately for each of these transitions. And you know what? I'm going to put this is the table from exercise 1. Again, go watch it if you haven't. I'm going to put it right over here. And then basically, we have to prove every single row of this table and how it works. All right, so we're going to look at the first one, which is Q0 is the current state. You add a symbol 0, and then the new state is Q1. All right, so appending the 0 yields a string with a 0 at the end. Of course, duh. We have something, you add 0. Obviously, 0 is the end one, right? And that is actually required by the Q1 invariant. So that one checks out for now. And then we also require that the second last symbol is not a 2, right? And it follows from the Q0 invariant, right? And finally, we want that the new string has no bad zeros. Now, that is also good to go because if there is a bad zero, Q0 to Q2, because that's the only way you can come to Q1, those guys will take care of each other and you can't come back from Q3, so it doesn't really matter what's coming from Q3. The only time that there might be a bad zero is that your string has 2 zeros at the end of it back to back, and that is not even a bad zero because before that second last zero there has to be a 2 because it's coming from Q2, right? And it's preceded by a 2. So that case we're good to go to. So basically when we go from Q0 and then we give it a 0 and we go to Q1, it still holds for that invariant. Now, if you look at the second row, if I'm at Q0, I add a 1 and I go to Q0, right? There is no bad zeros now. You know what I mean? Like we don't even have zeros, right? Even if we had, because invariant Q, the originally one, is already agreed upon and it works, by adding 1, you're not adding any zeros in there anymore. So there is nothing threatening the correctness of this DFA. So the string ends with a 1 and this works. Now I can go through all of them. I can go through every single one of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 12 of them. Now, but I hope you get the idea. And if you don't, I mean, the slides are there. You know what? I'm gonna put the proof right here. But you know, basically, I don't want to just go over and read a script. I just want to clarify that that's how you kind of, you know, answer a question like this when they say prove that the DFA is correct. If you're going from this state, you add this string, and you go to this state, you have to prove that if this state was already true, assuming you already got here true, like, you know, with the correct way, if you add this new string, is it still gonna hold up, right? And that's the way you're gonna prove that the DFA is correct. You gotta make sure every single one of those rows is correct. And after doing all those rows, right, we can see that Q3 cannot be accepting state because it has at least one bad zero, right? It has at least one bad zero and it's not correct. So it becomes this, for lack of a better word, a black hole, and it gets stuck. Because once you get there, if you give it a 0, if you give it a 1, or if you give it a 2, you can't get out. So you're stuck there. Q1 has a 0 at the end of it and cannot be an accepting state, right? Because... Hi guys, this is post-edit. I kind of messed up over here. But Q1 cannot be an accepting state due to the fact that there's a dangling 0 at the end of it. Either there needs to be a 1 afterwards so it alleviates the problem, or there needs to be a preceding 2. But if you take a look at the graph, Q0, there is no way for there to be a 2, and the last time that there was a 2 was at Q2. So Q1 cannot be a accepting state due to that factor. Play around with it yourself and you'll see what I mean. Q0 and Q2 have no bad zeros, right? And do not end with a 0. So they are accepting states. If you bounce between them, it's fine. And therefore, after, you know, proving every single row of these and clearly stating what states are accepting states and what are not accepting states, we have therefore proved that our DFA is correct. And if any of that falls short, it's not correct. Basically, that's pretty much how you go at this type of question. Alright guys, that will be all for this question. I'll see you guys in the next video.